Alright guys, this is section 13.5, probability. Okay, so in probability, you're looking at all the possible outcomes in an experiment, which is called the sample space, and what you're trying to figure out is what's the probability or what are the odds that you will get a specific outcome, or maybe a couple of specific outcomes in a row. So that's all you're really doing, is saying, it's like if, a simple example, if you roll a dice, I'm going to say what's the probability that you're going to roll a 6? Well, unless it's a weighted dice, the probability is 1/6, right? What's the probability that you're going to roll an even? Well, there's 3 evens and 3 odds, so the probability is 1/2. So that's what you're doing with probability. You're just trying to figure out what are the odds that you're going to get 1 out of all the possible outcomes, or a set out of a possible outcomes. Maybe you want a multiple of 3 or an even number, or if you're playing with a deck of cards, what are the probabilities that you'll get a face card? So it's not always going to be one specific thing. It might be a group of outcomes. But what you're trying to see is, out of all the possibilities that could happen, how many of them are the outcome that I want? Okay. So for example, oh look, they use dice. An example 1. So you have an experiment, a simple experiment is rolling dice. What is the sample space or set of possible outcomes for this experiment? Okay, so what are your possible outcomes if you're rolling a dice? If you're just rolling 1, 1, 2, 3, 4, 5, 6. Sorry, if you're rolling a die, which is a single. So that's it, that's your sample space. 1, 2, 3, 4, 5, 6. Those are your possible outcomes. Now, in example 2, you're going to choose a random 2-person committee from the following people. So you have Jack, Sue, Valerie, Bill, and Kim. So they want to know the sample space. That means that I don't only want to know how many possibilities there are, in which case you could use your little tree, right, where you could write Jack, and then the second person can be any of these 5. They want you to actually tell them, okay, what are all the possible combinations? Remember, it's a committee, so Jack first, Sue second is the same as Sue first, Jack second. So what are our possible combinations? We can have J with S, J with V, J with B, J with K, and now we're done with J, right? So now we go S with V, S with B, S with K. Done all the possibilities for S. V with B, V with K. Done with V, B with K. That's our sample space. Now it happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. But the sample space is you actually telling them what all the possibilities are. Okay? Now, a subset of a sample space, which is what's happening at any particular time, is called an event. In the case of the die, 1 roll is an event, and your outcome is what happens in that event, right? Now, outcomes are equally likely. Most of the stuff we're going to do, I think, all your outcomes are equally likely. So we'll go back to the example of the die, and actually we can go back to this example. If you're just randomly selecting these people, so if you're pulling names out of a hat, then Jack has an equal probability of being selected as whoever Bob was, B was, Bill, sorry. So they're equal probabilities, which means you can, when you're trying to figure out numbers, what are the odds that something's going to happen, you can weigh everything the same. With the dice, the same thing. There's as much of a shot of getting a 1 as getting a 6. So they're all weighted the same, which allows you to do these probabilities and these outcome measures. If there's not the same probability of everything happening, you have to change how you're doing your calculations. But everything we're looking at is where all the outcomes have the same probability of happening. So what is the probability of an event? It is the ratio of the number of favorable outcomes. Favorable doesn't necessarily mean good, like if you're trying to win Monopoly and you get a 6, that's not favorable. Favorable is if I'm saying, what are the odds that this is going to be a 5? A favorable outcome is 5, because that is the outcome that I'm looking for. Same thing here. I'm saying, what are the odds that it's going to be Sue and Valeria? That doesn't necessarily mean they're the best. That means that's what I'm looking for. So that's going to be a favorable outcome. So it's the ratio, we're going to do it with the dice because it's easy, of getting, say, number 5 over the total number of possible outcomes, which in the dice is 6. say we're moving on to this committee and you really want it to be Bill and Sue. So you say, what's the chances that both Bill and Sue are going to be on that committee? I'm going to say, well, it's one potential outcome out of a total of 10 potential outcomes. Okay, so that is the probability of that particular event. Now, what are the basic probability laws? There's 5 of them. And I'm not going to ask you to regurgitate these, but it'll probably help you when you're doing your calculations. Some are a little more straightforward than others. So, the probability that an event is going to happen, the probability of an event that is certain to happen is 1, right? So it's 1 over 1, 100% probability that that is going to happen, okay? I'm trying to think of anything that's 100% given. The probability that it will be Tuesday after it is Monday is 100%, right? The probability that if today was Monday, yesterday was Sunday, also 100%. Really, I don't think there's any calculations that we're going to be doing that have 100% probability, so we're never going to see a probability of 1. Now, the probability of something impossible. So what is the probability that I'm going to be here tomorrow teaching you guys algebra in person? 0. Not going to happen, right? 0 over 1, so it's 0. Probability of something that is 100% given is 1. Probability of something that no way is going to happen is 0. All of the probabilities we're going to be dealing with are going to be somewhere between 0 and 1. So they're going to be larger than 0, smaller than 1, which means they're all going to start with and then a number there. There might be a few zeros before the number, or there might just be a number. Rule number 3, if the probability of any event is between 0 and 1, right? So 0 is less than the probability of an event. Because yes, the probability of an event could be 0. Nothing that we're going to deal with is. Nothing that we're going to deal with is actually 0 or 1. So all of our events are going to be greater than 0, less than 1. Otherwise, what's the fun of running any numbers on it, right? Now, if the complement of an event, think about what complement is. So in geometry, for example, which you guys fortunately aren't doing, complementary angles are 2 angles that add up to something. In this case, 180. So it's 2 that add up to something. So a complementary event would be an event that's not the event that you wanted, right? So the complement of an event is the set of outcomes that are not the event that you wanted. So if the probability of your event is that, the probability of its complement. So if we were rolling the dice, the probability of your event, say you want to roll a 5, would be 1 out of 6. The probability of any other event would be 5 out of 6, because it would just be 1 minus 1 over 6. Now in blackjack, for example, which you guys don't play because gambling's bad, but what you want is to get a 21. What's the probability of you getting a 21? It's complicated because there's lots of different combinations, but let's just say it's 1 in 15. And I'm sure it's way worse than that, and as cards get dealt, it's changed. But say you're right here, and you've been looking, and you have to decide whether or not you want to get another card. The probability of you getting a 21 is 1 out of 15. What's the probability of you not getting a 21? Which is the complement? 14 out of 15. Which is why gambling is bad, which is why the house always wins, right? But the complement of an event is everything but that event happening. And since it's everything else, obviously the 2 have to add up to 1. So that's the 4th rule. I don't even know when we're ever going to use that, but that's the rule of, that's a probability law, sorry. And the last one is if A and B are 2 events such that A, I like to write it like this. That just means that they're mutually exclusive, right? That's assuming that the probability of nothing is 0, right? The probability of both of these happening, the probability of A and B happening, I tell you is 0. So when I write that, I mean A and B, but I would probably tell you guys just because I'm nice. I'd say the probability of both of these things happening is 0. That means that both of those events are mutually exclusive. If A happens, B cannot happen. and if B happens, A cannot happen, okay? So they are called mutually exclusive. And if that's the case, then the probability of A or B happening is just the probability of A plus the probability of B. So let's use the dice again to make that make a little bit more sense. I like the number 3 and the number 5 because they're prime numbers. 1's 1, so it doesn't really count as a prime number. So I'm gonna say, you know what, Brinley, roll me a prime number. And so you have to figure out what are the odds that you're gonna roll a prime number. Well, there's 6 possibilities, right? And they're mutually exclusive. If you roll a 3, you did not roll a 5. And if you rolled a 5, you did not roll a 3, right? So the probability of rolling a 3 is 1 out of 6. Probability of rolling a 5 is also 1 out of 6. So you actually have a 2 out of 6 or 1 in 3 shot of rolling a prime number when you roll a 6-sided die, okay? So that's what that means. And those are all our rules, and there's a bunch of derivations and explanations for it. But let's look at example 3, and then I think you guys can get going with your homework. It's a lot of wording for something that's mostly makes sense. So let's try example 3, see how complicated that is. And I did do all of these already, but I tend to forget. So you're forming a social committee of 4 people. You have 5 boys, and you have, nope, I think it said 4 girls. Yep, and you want to choose 4 people total. Just 4 members. It doesn't say how many girls or how many boys, at least it hasn't yet. They are randomly selected. So what is the probability of choosing an all-boy committee? Okay, now, choosing a boy and a girl are mutually exclusive. However, choosing a boy in the first for your first position and a boy for the second position are not mutually exclusive, right? So what we have to do is figure out our event. First event, we have 9 members. What's the probability that we're going to select a boy? Again, we're just picking it from a hat. So the probability is 1 out of 9, right? That we drew a boy. Well, now we're down, if that happened, to 4 boys and 4 girls. So what's the probability that my second event is also going to lead to a boy? And I'll tell you guys why we're doing multiplication in a minute. Well, it's 1 boy that I'm choosing out of now 8. Sorry. This was 5 out of 9, right? Because I could have chosen any of the 5 boys. Now I'm down to 4 boys out of a total of 8. So I'm down to 4 out of 8, except we know that that's just 1 out of 2, right? That's my second event. Now I'm at my third event. I'm down to 3 boys, 4 girls, which means a total of 7. So there's a 3 in 7 possibility that I'm going to get a third boy on there. Now if I do in fact get my third boy, I'm down to 2 boys and 4 girls. So I'm down to a total of 6. So what's the probability that I'm going to get a boy? 2 out of 6, which we know is 1 out of 3. Okay? Now, why are we doing multiplying instead of adding? Because I'm not saying what's the probability that I'll get a boy here or a boy here. I'm saying what's the probability that I'm going to get a boy here and a boy here and a boy here and a boy here. So you have to multiply them every single time. Now they're doing the number of favorable outcomes over number of possible outcomes. So they're doing a combination approach. In the book, let's see if mine gives us the same answer. And I'm going to multiply all this without a calculator. So let's see, it's going to be 5 times 1 times 3 times 1. So that's going to be 15, right? Bottom, 9 times, it's going to be a little bit harder. 9 times 2 is 18. 7 times 3 is 21. I got to do 18 times 21. And if you guys don't do multiplication like this, just ignore me. 8. I have to simplify it. What can we divide this by? 3, I think is going to be 5. Again, this is not how y'all do division, but it's okay. 5 over 126 is the math I'm getting, which is also what they got, okay? So, this is the way I did it, because it was relatively small and I was able to just visualize it, right? I didn't remember any formulas. I just knew, well, if there's 9 possible people and 5 of them are boys, what are your odds? 5 out of 9. It makes a lot of sense, right? Now, the way they did it is they did the number of favorable outcomes. So, how many favorable outcomes are there? Well, how many possible combinations of 5, because that's the total number of boys you have, with 4 boys? Right, that's the number of favorable combinations, and that's a formula if you want to remember it. But you can probably do it like this a lot of the time. Over the total number of possible outcomes. What are the total possible outcomes? Well, your total n is 9, because there's 9 people. It's the number of combinations of 9 committee members, of 4 committee members out of a total of 9. Your total favorable outcomes are 4 committee members out of a total of 5. So it's a little bit different. How do we do those combinations? Remember, I'm going to do this guy here, and then we'll divide them. It's 5 factorial over 4 factorial times 5 minus 4, also factorial. So on the top it's just going to be 5. You know what? Let's just write it all down. And then 4 factorial is 4 times 3 times 2 times 1. 5 minus 4 is just 1. So it's just 1. Remember, the ones don't matter. And then 2, 3, 4 can come out. So up here, we're going to have a 5. That's this. What are we going to get down here? 9 factorial, 4 factorial times 9 minus 4, the whole thing factorial. I'm going to write it all out. Again, I think we figured out how to get it on the calculator, but it's not that big of a number, so it's easier. Over, then we're going to do 4 times 3 times 2 times 1. 9 minus 4 is 5, right? Okay, the 1's come out, and then we can take 5, 4, 3, 2 out. Is there anything else we can take out? Well, if you do 4 times 2, you get 8. So we can take 8 out. So we have 9 times 7 times 6. 9 times 7 is 63. I'm going to do 63 times 6. So I'm going to get 18, remaining 1, 36, 378. So it's 9 times 7 times 6. Perfect. Over, what's at the bottom? 3. So this is my denominator. This is my numerator. So I have 5 over 378 over 3. So remember, you can just flip the bottom one, and so you get 15 over 378, which is what I got here. And then you just simplify it, right? So 2 different ways to do it, you get the same answer. And it depends on whether you like this formula, which I know Anna Kate does not. And it also depends on how big the number is. If this was a committee of like 14 and I had way more, maybe I wouldn't want to do all this multiplying. So it's just 2 different options, okay? You can do it using this formula. This formula always works, but you might forget the formula. So if you forget the formula, your numbers are small enough, just look at each event and say, okay, how many of these are my favorable outcome, the outcome I want? How many possible outcomes do I have? And remember, if you want something to happen and something else to happen, you have to multiply it. If you want something to happen or something else to happen, you can just add them. And it kind of makes sense, right? Because the odds of 2 things happening should be smaller than the odds of just one of those things happening. Whereas the odds of one or another thing happening should be larger than the odds of either one of those things happening on their own. So, 2 different ways to do it. You can use either one for your homework, and you're going to do number 1 through number 18.